Phil. Don't know how many of you all have some questions, but I did see one that did come in. So again, take advantage of this Q&A box. Just send them in. The question so far that we've got coming, Phil, was what's your experience working with the IDT HT test, and how do you feel about it replacing the APA?
Hey, Trenton. Yeah, I was going to turn my video on, but don't know if it will. I don't think it's going to. It's just saying it won't let me start it. So I'll try that again here in a moment. But glad to jump on that one again. I've actually used the Ideal. We played with the Ideal RT, Ideal HT. I tend to like the Ideal RT a little bit more, just because that I think it's got. I think it's a little cleaner on what it's doing. Ideal HT should do the similar. The difference is one puts it in shear versus the other one's just a high temperature tensile strength. Right now, what I'm seeing is it lines up well with Hamburg, but it's going to be a lot like what we would do with Ideal CT. It's going to you're going to have it line up for one mix, such as a 6422. However, you're going to have a sort of a different value for a 76, but even more so with a polymer versus one polymer and another, because what it's not doing a repeated loading on it. But from one mix to another, we can absolutely do our design, for instance, with an APA, and then go to the field and say, well, the RT or HT is about this value, and this is what I'm looking for. So I like it. Matter of fact, I saw a really tight on the airport project we monitored with just this past summer. I saw a tight correlation with Hamburg on that one specific mix.
All right. Another question that came in was, we know the HYMA has some crack resistance capability, and for everybody, it's a highly polymer modified binders. Do you know how it performs in the Ideal CT? Does it show the full benefit?
Oh, yeah, great question. Personally, I don't think Ideal CT can capture the full benefit of any of the elastomeric products, and let me show you why. I've actually got a sample that I sort of keep this here. When I run an Ideal CT test, and I'm just going to play with it like this, I'm pushing on it and it puts it into tension. When it does that, I'm pulling this sample apart. And it will absolutely do that. And this sample will snap back. What the Ideal CT can't do is pull it, let it go, pull it, let it go, pull it, let it go. And that's that repeated loading that I won't see a true benefit with HYMA, any polymer, aramid fiber, any of those products. But you will see the basic benefit of the initial strength and the cohesion it creates on the mixture.
Another question that came in, it says for the wrap study you did with is either 35, 36% wrap fiber and bio oil. What temperature was used for 4-hour cure and 8-hour cure, and how many years service is that roughly estimated?
Oh, okay. Yeah, great question. Great questions. So we used we were using our standard mixing temperature that we were estimating, trying to get it to a 6422. So we used 135C for the 4-hour, for the 8-hour. There's a lot of discussions out there on the practical versus reality. So let me take it to the high theory world. And Mike Anderson had a great article on this. If I want to put down a pavement and watch it for 20 years, 15 years, that's the best answer. Or I could elevate the heat, watch it for 10 years or 5 years or so on. I'm more in the side of putting a little more heat on it up front, trying to understand what's going to happen. I know it's not perfect, but it gets us close. With that, I think that the 4 hours just gets us to construction. That's about where you're at. If you go take a sample, heat it up, let it cool down, get it on the roadway, and it cools down, you're probably at around 3 to 4 hours. The 8 hours, the additional time you're putting on it is a few years. Ballparking, if I were to take that out, let's say 18 to 20 hours on some airport work that we did when I was at Asphalt Institute, maybe you're representing about 10 years on some binders, and other binders it may be more. There's a bottom line is more aging time extends it out. And if we can get something to get us in the ballpark of 8 to 10 years, Trenton, I think we'd be a lot better off than where we're at. Whether it's 8 hours or 16 hours or 20 hours, more gives you better insight.
All right. Another question. This has to do with rubber. So maybe we'll ask it two ways: the ground tire dry process, as well as the rubber modified binders. But as an additive, how could that affect the ideal CT, the Hamburg wheel tracker, and the density of the mix?
Okay. So let me speak on the wet process first. Wet processed is naturally more expensive, but it's also more dispersed. You can measure it in your liquid properties, very easy to see. As far as what we're seeing in the ideal CT, I think jury's out on that one. I think it's going to fall in the ballpark of just what you're seeing with the other polymers, and how it works within that, and is it going to actually show you the benefit where you're hitting it, letting it relax? We can't do that in an ideal CT. Does it have benefit? It's proven to have benefit over time. We've seen, California, Arizona, Florida has shown benefits of it, just like polymer. Now, switching to the dry form of this, you should see the similar benefit. There's subtle differences between them. I don't think you'll see the full benefit in ideal CT. So just be aware that I think it performs better than what ideal CT will tell you. But the other thing you got to be aware of, there's also just like certain products will absorb asphalt, rubber can absorb it, right? And it's going to go in there and it's going to swell. And you have to talk to the manufacturer to understand that swelling and what all's going on. So not a rubber expert on that, but my opinion, I think ideal CT is a great tool. It's just it's an index. So we have to understand how it works with all these more luxurious options.
Yeah. And you were pointing out to the aramid fibers, you were pointing to the bio oils. Within this whole space, we see a lot of new innovations coming into play. And I think you pointed out a couple slides back, just the challenge we have just looking for a 64 to a 70-22 binder. And we've heard plenty of discussion over the last few years of our 76 binders that are polymer modified. The targets we set for that ET-CT really just, they don't make sense, or it doesn't capture what we know polymer modification does. So the same with the ground tire rubber on the dry process, the wet process. So we have all that going on that we really are trying to figure out is, all right, we got to set a criteria. But is the criteria applicable? Is it, as your one graph showed, is it possibly moving the testing temperature? You did 20, 25, and 30 C. Right, 68 degrees Fahrenheit, we're not seeing the initiation of cracking unless you have some
That's right.
crazy things going on. So does it make more sense for, as our binder grade increases, that we look at, it could still be, say, a 70, but for a 64, a 70 is at 25 C, but at a 70, maybe it's enough. So, I mean, those are the things that now as we're getting into, we're asking those questions.
Yeah, you're hitting on a really good point. One thing I encourage agencies to do, for instance, if I run the ideal CT and I'm in Canada or northern US and I have a -34 binder and I run it at 25 C, I won't actually break the sample, it just bends it. So it's got to be adjusted for the climate you're in. In the specification that was written for ASTM, the recommended temperature is your high and low divided by 2. So, and then just to help you see where we're at. So that would be your when you take your high and low divided by 2, and then you're going to add 4 degrees back to it. So that's how we end up at these numbers. I say high and low, not the average. The high minus the low, and then divided by 2. So that's how we're going to get into that range of the 25C that we're sort of seeing for Texas. However, for Kentucky, we elevate our numbers. Maybe the better number for us would be 21C. But when you throw the 7622 in there, now you got a different number. I do think, Trenton, we're going to see softer binders. If we're going to be using wrap, we'll be looking at softer binders, and that can be a challenge for refiners. So I think that's a question we need to ask the refiners is what's our best options to be able to get these type of products going forward.
Well, and I think some of your graphs showed like what the bio oil did for the stiffness on those mixes. Question that we've just debated back and forth within our office is, does something like a GTR provide us that flexibility on the low end? Because the way we're utilizing recycled, that one graph that you showed is still a 6422, but just the differences in the test results, and it still met 6422, or
yes.
Virginia 64S minus 22. It still met the criteria for the spec, but it had definitely different results or outcomes when we moved to performance testing. So one of the things, and you mentioned NCAP, Buzz Powell and I had conversations several years ago, is something like an IDT CT type test a way to check your binder that's coming in from your supplier, depending on, is it coming from a refiner, or is it coming from a third party that's grabbing from all sorts of different sources? Knowing, and intuitively we knew, and just watching the impacts of aggregate and binder. Well, if you take a sample and you know exactly what's in that sample of aggregate, purely virgin mix, and you add, just like you said you do with wrap, say you add 5% to it, and now you said as your baseline, I got these results from my IDT CT, and another tanker or two comes in, you can take that exact same wrap, that same virgin aggregate, add 5% to it again, test it, and you can see, are you better, the same, or worse within the variability of the test itself of that binder. So it gives you as a producer a whole lot better comfort that what's coming in and being dumped into your liquid tanks is as good or better than what you designed upon. And so we have these tools in place where you don't have to go to an elaborate binder testing facility, that a contractor and a producer real quickly can check to see, am I getting consistency? Am I seeing some changes? Because that'll impact me on other test results pretty quickly in a quick turnaround.
Trenton, we chased for years to have a good test at an intermediate temperature that could predict some of what we're seeing. And there's some tests out there that can help us. We've got the high side down really well because it's very defined in a liquid form. We got the low side down really well because we approach this glassy transition temperature. But this intermediate temperature that we're in, really difficult to nail on the binder side. And so that's why, as a refiner, they may have 164.22, and it looks like this one day, a crude slate changes slightly, that gets pushed downstream. It's still meeting 64.22. The refiner didn't do anything different other than switching some slates. We still get a 64.22 that meets spec, but it could look a little different. And it may take bio oil different. It may modify differently. So there's so much going on. But another thing you can do with your wrap, and that's what Buzz is a good one on. That's on the practical side. Nathan Moore, Jason, all those guys down there. One thing that they've done and I've adopted is just take your wrap, pile, heat your wrap up in temperature, give it a stir, throw it in a compactor, make you a sample, test it in ideal CT. Understand what your wrap is on a daily or weekly basis that you're blending in, especially if you're using a high amount of wrap, and that will help you. If you see your wrap CT drop, typically it's probably going to be 20, 10 to 20. But if you see it drop or raise, that will also give you an indicator of how it's going to impact your mixture.
A question did come in. I think we've sort of touched on it already, but it was just which temperature is more appropriate for the ideal CT? Is it a 25C or a temperature according to PG binder? And, you touched on that briefly, but your graph definitely showed the impacts of testing temperature.
Right. Oh boy, that's a hard. So the purist in me, if I'm running a real fundamental test, okay, fatigue testing or rutting or something, I'm going to say, don't define it by your PG, define it by the climate you're in. So if I'm in, and by the way, Kentucky's more of a 58-28 climate, but let's say but we use 64-22. Let's say I'm looking at a 64-22 climate, looking at intermediate temperature, 64 minus 22 gives me that 42 number. 42 divided by 2 is 21. 20, and this is what we've defined this even within the binder grades years ago. 21 degrees plus 4 degrees gives me my 25C. That's how we come up with that number. That works great for fundamental testing. However, I think because of how we're going to have to trick it for these 76s and things, I think we may end up, if we want to get the same number, we can do one of two things. We can either accept a little lower number for some of our 76s, or we may want to increase the temperature enough, just a little bit to come up with a similar number for your 76s. So I think we're going to have to trick the test. And as a good friend of mine said one time, he said, as you implement new technology, don't take an amnesia pill. Remember where you've been.
Yeah. Question came in, you touched on it a bit, but how does the aramid fiber help or improve the mixture properties?
I've got I say limited knowledge, but I've been working with it since 2016. I was reluctant first to really, I thought it was just another fiber. And I realized, when I touched it and looked at it, it's really not. It adds, it's like rebar in concrete is the best way I know how to describe it. It adds something that we haven't seen in asphalt. So you got to sort of approach it from a different mindset. Does it help in rutting? Yes. Does it help in low temperature cracking? Yes. Fatigue cracking? Yes. Does it help in your mid temperature cracking? Yes. Does it help on structural? Does it help it act as a better structure? Yes. And I've used it in heavy parking lot design. So it's sort of in all categories. Yes, it works. And as University of Rowan's working on some stuff, they said one thing they like about it, doesn't change the mix design. So from that perspective, being locally available, where you can get it there, and it's available when you need it. I like it. I think it is a up and coming. It's one of those ones I put it on my watch list. Up and coming product. I think you are going to see a lot more of it. It just makes the mix better. I haven't seen it make a mix worse yet. I know that everybody likes to vet it and look at it their own way. Right now, it's on the NCAT track. It's on Min Road, so keep an eye on it. But for me, that's where I'm seeing benefit. I proved it myself, and that's a good one to keep a watch on.
When you use the aramid fiber, and the reason I asked this question, you mentioned the Research Council, and they've done some work. Stacy Diefendorfer and her team, they did the drop-in method. Did you redesign to get a better asphalt content? Those fibers have surface area, so they're going to, pull just like cellulose fibers does in SMA. But we saw the differences in some of the test results from just a single drop-in approach, and then if we'd have possibly bumped up the binder content to have better overall coating and film thickness, we may have seen different test results. What are your thoughts on that?
Yeah, I only see it improve, so I may have to look back to understand what you saw. This is typical cellulose fiber, Trenton, as you know. It's a sponge. It goes in at 0.03% or
0.3.
Yeah, 0.3%. Okay, 0.3%. And it goes in the mix at that. Yes, aramid fiber goes in also and has surface area. As you see, very different. This is an engineered fiber. This
Mhm.
product goes in at 0.00667%. That's why when it goes in, I've tried to redesign with it, and it does not change asphalt content. It's got surface area, but it's so lightweight. Um, it just doesn't change it. Matter of fact, it doesn't change any of the properties. I was thinking one time I may have seen it boost BMA a tenth, but I don't think so. I think it's more just error in what I was in, just error in gravity calculations. So uh, not just me, but others have looked at it, and University of Alberta looked at it, and they actually put in 10 times the amount. So they put in 0.06%, and it did not change their volumetrics. So maybe something to relook at there, because I know Stacy and Johnny do good work, but you should see a bump in all your performance factors.
All right, a couple more questions coming. How do you feel about the delta TC values in the binder? Is that something we need to learn more about going forward with BMD?
Yes, I like it, and and you do get two different values. One of the if you use a 20-hour PAV and run it in 2 cycles versus 1 PAV and you run it 40 hours, we prefer to do the 40. Delta TC is something that Mike Anderson, when I was there, we were working together on a project. Gal King, others were on that one, but bottom line, it was a way, and it's been around for a long time, but it's a way to give you an indicator of the difference in the way the binder fails versus its stiffness when you load it versus the slope of how it relaxes. Both of those should fail, let's say at minus 22 degrees. But if one's failing at minus 20 degrees and the other one's failing at minus 26 degrees, that's where you get your delta TC. And the minus version of that is bad. A plus version is good. It is right now it's an incredible indicator at helping you understand binder quality. Illinois has implemented it. Kentucky's talking about it. I think you're going to see more and more of delta TC.
All right. Question also came in: would aramid fiber tested in Hamburg show more improvement with higher aged mixture, i.e., do tensile strengths of the fiber take hold in later life and across micro cracks?
Yeah, okay, boy, that's a good one. That's one you need to take somewhere in debate.
That's why I'm asking it and you're answering it.
Yeah, there you go. It's Phil's opinion. I don't see this product aging. Okay. And I've put it in acid. I've done different. I don't see the product aging. When it gets in the asphalt, we rely on the asphalt to hold it in place. Asphalt loses light oils on the surface, especially the top 1/4 inch, 1/2 inch. And then at some point you hit a point where you won't lose those light oils. The fiber still holds on. The better the mix it's in, the better it's going to work. I do believe there's benefit long term. I know I see the reduction in cracking, and so if I see the reduction in cracking, big cracks, I would assume it would do it in micro cracking, Trenton. So I think there's benefit there. It's just we just got the longest project that I have monitored so far is 8 years. And I'm seeing benefits of 70% reduction in cracking, and we'll keep looking at it.
Yeah, last week here at the Mid-Atlantic Asphalt Expo, we celebrated our Golden Loot, or the best project in Virginia for 2022, and that project was done in the city of Richmond by Lehigh Construction, and in the mix that they used, it had 30% wrap, 6422 binder, and had fibers in it. Again, as a way to really try to extend the life of the mix in a very challenging and highly trafficked area. Yes, you have a lot of commuter cars, but you also have a lot of businesses. So you have a lot of delivery trucks. At times you have, with the construction going on, you have concrete trucks, you have dump trucks. So there's a lot of loading going on, so that the city made that determination with that project to add the fibers to it. And a lot of places here around the country, we've we see more fibers being looked at, understanding them. You know, is that dosage rate? Yeah, could very well be. I'll take your word that it doesn't increase enough surface area that changes. If you got a 5.6 asphalt content without, probably a 5.6 width. And when you consider the fact that then you put it through an asphalt plant, you've got variability just during production. So even if it is a slight difference, once you go to production, seeing the up and the down on production, you're not going to be able to tell the difference. So again, it's these things that we're learning about, again, as we focusing on this specific webinar and the More You Know series. Is that's what we're trying to do, is help people understand the more you know about the technologies, because we need to continue to advance toward performance based mix design, understanding what volume metrics are or not. They're great if it's a virgin mix. The more things you add with different gravities, that changes really the accuracy. You know your rice, you know your GMB, but once you go beyond that, now you're starting to make assumptions, and we all know about what happens when you assume.
Well, let me throw this out. You know, when they talk about dosage, they talk about 2.1 ounces per mix ton. If I was a contractor, I would look at, in my mixture, I'd look at 2 ounces, I'd look at 2.5, I'd look at 3. It's just a number, right? And so find out how much you need. And the reason I go with that, same thing with the bio oil. I continue to say, and I love to explain this to contractors, the day of the contractors here. This is just like we saw with the concrete industry, and I'm sorry I said that word, just like we saw with the concrete industry. You go to a plant, they buy super plasticizers, you put it in, you put retarders in. I think you're going to go to a hot mix plant, and where we've got to take the handcuffs off is we've got to be able to allow the contractor to put in products that they need, like this one, they flip a switch, this one they could flip a switch, instead of having to do everything so upstream. That's also going to challenge the contractor, that the contractor is going to have to bring the quality to the table to be able to do that. But together, if we bring options like this to where we can turn switches on and off and it just mixes on the fly, imagine the flexibility we would have for intersections, whatever we need. Now you've put the hot mix control truly in the hands of the contractor, but she will also have the tools such as Hamburg or APA or Ideal CT and Catabro to be able to adjust it as needed.
Great point. Well, we're coming to the end of this webinar, this Lunch and Learn. This has been recorded, so it will be available on the VAA YouTube channel. So you'll be able to find it there if you have any trouble locating it. Also, feel free to share it. You know, while we had a great attendance today of around 50 or so folks, trying to coordinate everybody's calendar and their time is really tough. So that's why we record this, so it can live on. So definitely share it. Take the time. If you have any questions, at the beginning you saw Phil's email address. Of course, you can contact us here at the Virginia Asphalt Association, and we're more than willing to either answer your questions or put you into contact with those that can answer your question. So with that, I don't see any more questions coming in, Phil. Those that attended, that registered, will be eligible for the continuing education credits that's available through this webinar. But with that, I thank you, Phil, for all your time and for doing this with us, educating us, as again, we're moving toward that performance-based mix design, balanced mix design, so we can utilize all the tools to not only help the contractors, but really at the end of the day, help the taxpayer that pays for so much of the work that we do. So with that, I thank you very much. Have great holidays and Christmas, and we'll see you and everyone else soon.
Thank you. Take care.